And we will do a real quick lesson before the exit ticket because we're not going to even get to everything that's going to be on the exit ticket. But everything we do today will be on there. And there will be one more piece that will be on there that we'll do on Friday before the exit ticket. So that will be fresh in your head there. For the bell work, hopefully you did it. I'm going to just go ahead and do it pretty fast because we need to move forward. For a y-intercept, here's what I'm still having some people. Oh, if you're taking a quiz, like if you have a 0 for a quiz, which a lot of you do, you need to come in after school to take those quizzes. I'm really going to try to avoid doing them in class because then you just miss a lesson and now you're behind. So come in after school. If you need to break it up and do it during lunch, like over 3 days, we can do that. Preferably plan to be here for a full hour, like try to get, or if you walk home, you can just walk home on your own later. If you have a ride from a parent or guardian or somebody, ask them if you can stay an extra 45 minutes and have them pick you up, then you can get it done. If you can't do either of those, then we'll have to break it up, but it's just a lot harder the longer you wait, first of all, so try to do it soon. And then breaking it up into sections, I think, is harder to take a quiz than just getting it all done at one time. All right, so here we go. Y-intercept, visually. I graded it in other periods. I'm not going to grade it here because of the active stay on thing.
Do we have a test this morning?
Well, exit ticket. So all of this will be on your next big quiz too, though. The y-intercept. Here's what I'm still getting from some people. And again, I know I'm a math teacher and math's my things, but it's still hard for me to understand why some things are tough. So that's where I need you guys to try to help each other or help me understand. This is the y-axis. That vertical number line. I've started to call it a number line a lot because it is a number line. It's not even a real thing. Like it's not a line that they graphed. It's just a number line, an imaginary number line that allows us to put data on a graph. If you just had a blank piece of graph paper and I gave you a coordinate, you'd have no idea where to put it. There's no numbers. So this is just like an imaginary line that allows us to put something on the graph paper. Well, let me go back. So that is the y-axis. A lot of you, when I say y-intercept, are still thinking that whole line is the y-intercept. It's two totally different things. That line is the y-axis. The y-intercept, in green, I'll do a different color, that is the one single point. It is one point and only one point. Where the line on the graph is crossing through or over the y-axis. So it's one single point. And it's represented by the variable b. Remember when we had that equation, it was y equals mx plus b? B is just a variable that stands for that y-intercept. So we would say, what's the value? Those of you that were able to get this done. Or hope you got it done. What's the second part? What is the y-intercept for that? 0. So we would say the y-intercept for this line is 0. Or we could say b equals 0, because they're the same thing. Y-intercept and b are the same thing. Like when we say that. So I'm still getting a lot of kids confusing what an axis is versus an intercept. An axis is the entire line. An intercept is just a single point where the other lines, like the graphed lines, are crossing through that axis. Any questions on that? Y'all got that now? We're about to find out. Oh, but I'm going to go to a different presentation to find out. Whoop. So what you're doing here, we're going to see if you got this down. I have 4 lines that I've put on there. They're just, instead of doing 4 separate graphs, I just put all of them on one line. That's why I made them different colors. So the black line, green, red, and blue. Then obviously you have the y-axis still in the x-axis. I want you to tell me for each of those lines, what is the y-intercept? And then you don't have to draw this out. I mean, if you want to, I guess you can. If you want to have it in your notes, it's going to take you a lot longer to do the problem. And then what is the coordinate, the x and the y value at the y-intercept? So I'm doing the first one for you. So for the black line, so the black line would be this line right here. For those of you that can't see it online, this is the black line I'm talking about right there. So for that black line, I just look at the line. I say, well, where does it cross over the y-axis? Well, it crosses over the y-axis right here. So what is the y value? What's the number basically at that point? Well, it's -4. So that is my y-intercept. I'll do it one time, and then after that, you're on your own. So please, you guys wake up. Yaja, please pay attention, even if you guys are headaches or whatever.
No.
Well, for them.
I got yesterday water spilled, someone spilled water all over my backpack. I don't have a notebook no more.
You can grab one of those if you want to start a new one over. See the composition notebooks. So then the next piece. So if that's my y-intercept, I want to know what is the x and y value at that y-intercept. Do you remember when we did graphing and I told you the story about the woman I almost married? This graph. Love that girl. She's fake. I love that. We said I did what to get to wherever I was going first? I went left or right first, right? Because I had to go to the elevator. So I went left or right first. Then I could go up or down. And that's the way we wound up grabbing points, is we went left or right first, then we went up. Well, it's become very clear to me that when we already have the point, we don't know how to write the numbers that should go for the x and the y coordinate. It's the same thing. You go left and right first, and then up or down. Your left and right number is your first number, your x. Your up or down number is your second number, your y. And you always start at the center of the graph. Well, the center of the x and the y. So if I'm at the center, so right there, how far left or right do I need to go to get to that point that I just put in black? How far left or right am I going? The only dot, the black dot.
Well, what do you mean?
How far left or right do I need to go if I want to get to that dot?
None.
None! That's the answer. Just think about it. If you were going to put a dot there, would you go left or right? No, you would not. So if you're not going left or right at all, it's 0. You don't go left or right. You're still on 0, right? If I go from this point and see where I'm at on the x-axis, I'm still at 0. I didn't go anywhere. I didn't go left or right, so I'm still at 0 up here on the x-axis. So my x value is 0. Next. Now, how far up or down do I go? Or to what number do I go up or down? I go to -4, so that's my point right there. Some classes really struggle with it. And I didn't expect it, so it took a lot longer, so we can probably catch up a little bit right here. So there, I did the black one for you. I want you guys, since you don't have different color markers, you can just write red, and then your number, and then your coordinate. Blue, and then your number, and then your coordinate. Then green, your y-intercept, and then your coordinate. So do the other 3. I'm going to walk around in like 30 seconds and see how we're doing. And see what I need to do to adjust. Some classes have done well on it. Some classes have really struggled on it. Some people in some classes have done well, and some people in some classes have struggled. I'll give you like another 15 seconds, and I'm going to start walking around. Please have something. Like I kind of have a model right there, so I know you don't have it right in front of you on your paper, but I think that should be, I mean, I can try to zoom in a little bit more maybe. Oh, no, I can't. That's definitely not good. Maybe I could zoom in here. Oh, there we go, yeah. There. That's about as much as I can zoom in and still keep that part on. Let's see. Where are you on? Looks good, I believe. I don't expect you to be excited. I don't expect that. All right. So what for the blue line? That's good. That's the first part of that blue. How far left or if you started the 0, 0, you were how far left or right are you going first? You would not be able to miss that. If you're at 0, 0, how far left or right are you going before you go over that line? How far left or right did I go from left? So what did what would that math number be? 0. There you go. Same thing. Good. That looks good. So we seem to be doing pretty well. Those look good so far. That looks good for green. Good. So for green, y equals 3. Well, it's actually technically it's b. Y is the variable. B is the y-intercept. So for the green, what number is that? Oh, I see what you're doing. Remember, it's where it goes through the y, the vertical axis. So look at that. There. And that'll change that whole, should change the whole coordinate. There you go. Good. So those look good so far. Those look good. All right. So we look like we're doing okay. What's the okay, so this is your intercept, right? So how far left or right, that green line? I'm going to this point right here, which you have correct. How far, so I'm starting here. You always start at 0, 0. How far left or right do I go before I go? I'm right here. How far left or right do I go before I go up to? Mm-hmm. The green. I'll be over there in a second, lady. I'm right here. Do I go left 1? Again, I want to get to that point, right? Do I go left 1? I go 1 left and then up. Am I on that point? Here you go. That's the answer. So just hang tight. Just make sure you can get the y-intercept part of it. If you're confused about the coordinate, make sure you get the y-intercept part. It's hard, a little bit hard to see that. You had it right. Yes, you can go now since you have all those credits. So we look pretty good, definitely better than a lot of the other classes on this, but I also taught it differently, so hopefully that helped. Or maybe you guys are just that much smarter than the other classes. So let's do the other lines. So I'll do green first. So again, visually, that's the y-intercept, where my green line crosses through the y-axis. So I'm going to write green. And most of you, I think, got that part right. You said the y-intercept is 2. Some of you are still struggling a little bit with understanding how to write the coordinate. And I think it's just because there's a 0 in it. that coordinate right there, I have to figure out where is it at relative to this number line. Well, it has to be, I have to be looking straight down. Because you always think left and right and up and down when you're dealing with a graph. You don't think diagonal at all. So, not for at least this one. So if I need to figure out where am I at relative to this x-axis, because I want my x value is always first. I think about going from here, left or right, to get directly underneath that point. Well, I don't really go anywhere. I stay right here. Well, if I'm staying right here, this number is 0 on the x-axis, right? Because I go 3, 2, 1, 0. So if that's the value, the horizontal value of this point, left and right, or if that's where I'm at above the number line, again, I don't know how to explain it. I've tried to explain it in 100 different ways, and some kids have gotten it and some kids haven't. So if you can explain it to somebody else, I would welcome you guys doing it in kid talk. But basically, I need to know where is this point if I were to move it here. How about this? If I were to take the point and move it down onto the x-axis, where would it fall? Or move it up if it's below the x-axis. So if I were to take this point, and you always are going to go straight up or down with the points, where would it fall on this? Well, it would fall at 0. So that means my x is 0. Maybe that's better. I like that way. I've never explained it that way. Maybe that'll work a little bit better. So now, same concept. If I were to take the point, and if I were to move it left or right to get it straight onto the y-axis, what number would it fall on? Well, that's pretty easy because it's already on the y-axis. So it would fall on 2. So that's the coordinate. So for those of you that couldn't figure out how to do the coordinate part, try it again thinking about that. So I'll give you the first part of the blue line, and then I want you to finish it up. So it's right here, and again, most of you had that. It goes through the y-axis right there. So now you need to think about where would that point fall on the x-axis if I just moved it straight down, and then where would it fall on the y-axis if I moved it left or right, or do I even need to move it left or right? Where would it fall on the y-axis? I'll give you guys a second, and I'm not going to walk around and look at those of you that were struggling, which was only 1 or 2 people, and I think even you guys had one of them right, but you're just taking a little while. And that's fine. Some people are just not as visual as other people, so I'm very visual. I hate words. So, again, what is my x value? So if I'm at this blue dot, and I drop the blue dot straight down onto the x-axis. So this is the x-axis. Where would it fall? Well, again, it would also fall at 0. So I would put a 0 then for my x value. So if I was going to take that point and move it left or right to get it onto the y-axis, well, it's already on the y-axis, so it falls on the 5 on the y-axis. And then I'll do the last one, the red one real quick. Same concept. It goes through. This was a little hard to see, so some of you might have gotten the wrong number there, but it actually goes through -1. Again, it would fall at 0 on the x, and it's already at -1 on the y. What do you notice about all those numbers? Or all those coordinates? There's a 0 for the x in every single one of them, right? That's always going to be the case. I don't care where you cross the y-axis. If you take that point and if you drop it onto the x-axis, like let's say we cross up here. Well, if I drop that down, I'm going to still be at 0. Let's say we cross way down here. Well, if I move that up to the x-axis, I'm still on 0. You're always going to be on 0 because the y number line, the vertical number line, is at 0 on the x-axis. Everything on the y-axis is going to be at 0. So you're always going to have a 0 as the x value if you're talking about the y-intercept. And then if you'll notice, the y value for the coordinate is just always the same exact thing as the y-intercept. Because basically that's where the point is on the y-axis. It's at that particular number. And we're going to summarize this, so if you're really, really not getting it, don't worry, we're going to summarize it at the end. So here's your next one. What is the verbal definition? I didn't go over this in the bell work. What's the verbal definition of the y? Like, what are you looking for on the graph? I'm going to call him Michael. What are you looking for on the graph to find the y-intercept?
To find the y-intercept?
Yep. The point where? What are you looking for? There's a bunch of points on the graph. Which point on the graph?
Where it goes to.
Goes through what? Final piece of that. What's it going through?
That x and y coordinate.
Well, the x and the y coordinate is the second part we did. It's where the line is going through what? So like visually, this line is going through what to find the y-intercept?
The y-intercept? X-intercept?
Well, the y-intercept is
Oh, I
the
just
single
said
point. What's the number line called going up and down?
Y-axis.
Y-axis. So what you are visually looking for to find the y-intercept. If you don't understand this, you need to write this down. I mean, we've gone over many times for the y. Wherever the line crosses, phone up please, Luciana. I was hoping you just put it away in your home. I want to see it in the backpack. No, I want to see it in the backpack. Not an option. Again, like I said, every time I stop, I'll be doing this. I don't know how to spell it exactly, but don't worry about that. Put it back. Put it back. No, let's not do this. So that's the second one. Because again, clearly you're not paying attention to the lesson, so you don't want to be in here, which is fine. So last chance. You just put it back. You're not being disruptive, so I'm not going to kick you out, but I'll give you the referral. So. All right. So visually, it's wherever the line crosses the y-axis. That is the y-intercept. What do you think the x-intercept is? Which is what we're on now. Yeah, it's just wherever the line crosses the x-axis. Same exact concept. It's just instead of looking for where it crosses the y-axis, the vertical axis, we're going to look for where it crosses the horizontal axis. So do the same thing for this problem. We are now, though, finding the x-intercept, so where all of these lines cross the x-axis now. So I want you to write, and I'll do the first one again. So I want you to write the line, like what color is the line? Find the x-intercept, so wherever it crosses the x-axis. So the number there is just 4. And then the coordinate, I would say is, so how far, if I start here, how far left or right do I go? Well, I go to 4. Or again, where does the number go if I drop it onto the x-axis or move it up to the x-axis? Well, it's already on there, so it's 4. And now, where does the point fall if I moved it left or right onto the y-axis? Well, it would hit 0. However, you need to figure that part out. I can't. No matter what I've tried, there are always some people that are still struggling. So you need to watch some videos or something, figuring out how to put a point on a graph or how to label a point on a graph. So that's the black line. X, remember we're doing x-intercept now. So do the other 3 lines for the x-intercept now. You already do them? Ben, you already do them? You did Y's. These are X. These are the new problem. X. Same exact thing, only for the x-intercept. We did y before, now we're doing x.
Oh, sorry.
How did you feel? You got one. Getting these right. You feel good about those? Good. Good. So you got blue line. So again, how far left or right do I go for the blue line? That's my first number. How far left or right do I go? Or where do I go? I go left or right, but to what number? Because left or right is your first number always. So what did you write there for your first number? Very good. You have the numbers correct.
Yeah. Wait, so we're going left or right to the starting point?
Well, you always go left or right. Left or right, the reason you go left or right is because a coordinate is always in that format. It's always x comma y. So that's why we go left or right, is because x is always the first number, and x is on this axis. These are all the x values. So that's why I go right first to 4, so that's a 4. Then I don't go up or down at all, so that's how I got the 0. So you're always going to be going left or right, even if it's on the y-axis. It's just when it's on the y-axis, the left or right number is just 0. So I didn't change anything with that. We were going left and right first every time. Well, first of all, just figure out where the x-intercept is. And then just tell me what the coordinate is. What is the x and y value for that point? So what else?
Did I do this right?
You did. Perfect. Fantastic.
Oh, I see what I did. I was going.
Well, that was a -6. It is a little hard to see from here, but you kind of almost have to just count out from 0. But looks like you're doing steps right.
All right, I know.
I'm not concerned about you writing the wrong number because you can see it. I already looked at it.
Hold on, I'm doing now.
All right, so I think everybody is pretty good. So I'm going to start. We'll keep working. Which one did you do first? So I don't give you an answer ahead of time. What? All right, so I'm going to do red also, so you can kind of check your answers as I'm doing it. So again, the red line, where does it cross the x-axis, the left and right number line?
-1.
Right there. So -1 is your first answer then.
Sure.
Wherever it crosses is the x-intercept. Now I just have to figure out, well, what is the coordinate? What's the x and the y at that? Well, my x is, again, the number that's on the x-axis.
0.
Well, no, the number on the x-axis is -1. That's your first number. Now, how far up or down do I go? Well, I don't go up or down at all. That's the 0. And then now I'll do the green. So the green line crosses right there. So 3, so I go left or right to 3. And then I don't go up or down again at all. So it's 0. And then last, blue. So the blue hits out here. Some of you couldn't see that number in the back. It's -6. So again, I go left or right first. Well, when I go left, I go to -6. That's the number I would be at. And then again, I don't go up or down at all, so I'm still at 0. What do you notice about all those?
They don't go up or down.
There's a 0 every time in the y this time, right? Before we had a 0 in the x. Now we had a 0 in the y. Again, same reason. If I'm on the x-axis, if I'm on the left and right number line, I'm always going to be at 0 on this vertical number line, right? I'm always right here. Doesn't matter how far left I go, I'm still right here vertically. I haven't gone up or down. Doesn't matter how far right I go, I'm still right here. I haven't gone up or down. So if you are on that line, you're always going to have a 0 in the y part of the coordinate. And then the x part of the coordinate is just always the x-intercept, which I forgot to write right there. So whatever number you're on the x-axis is always going to be your x-intercept and your x part of the coordinate. So here's what you're going to see on a quiz, and probably on state or district tests. This is the way you're probably going to be quizzed on this. Well, it is the way you'll be quizzed by me. I'm going to give you a whole bunch of points. Did I already say this? I feel like I'm repeating myself, but I just had fifth period. I'm going to give you a whole bunch of coordinates. Whoops. And it'll be more than that. Like, remember when we did slope and y-intercept and you had like 6 different problems and they each had a slope and a y-intercept, so it was like 12 different blanks. So there'll be a whole bunch of them. And I'm going to ask you, and there might be a line next to each, and in the line you have to tell me, is it a y-intercept, is it an x-intercept, or is it neither? Those are going to be your 3 options. So you got a 33% chance, even if you don't know what you're doing. Should get 100 on them. That's going to be one of the sections I expect you to get 100 on. Remember, I told you, I always create a couple of sections on the test where I expect you to get a 100. Then after that, the problems are a little trickier and it may be a little tougher. What is this first one? X, Y, or neither? What has to be true if it's on an X or a Y intercept? What do you have to have in there? What did we just do? Why?
Because if it was a y-axis, y-intercept one, then the x would be 0.
Perfect.
And on the x, then y.
All right, so I'll restate what Christine just said. If I am on either axis, if I'm on one of these, one of the numbers has got to be 0. Because if I'm on this y-axis, like if I'm on the vertical number line, the number line that goes up and down, I'm going to draw another one in a different color just to show you this. So if I'm on, here's my x and my y, right? X and y. This number right here is 0, 0, that coordinate. So if I'm anywhere on the y, like if I'm anywhere at all on this, actually here I'll do a different color. It doesn't matter where I'm at, where the point is on this line. And remember, if I'm talking about the y-intercept, I'll always be on that line because that's the definition. It's where it crosses the y-axis. No matter where I'm at on this point, the x value is always at 0 because I'm always right here. I never move on the x-axis. I'm always right there at 0. So I'll always have a 0 as at least one of the numbers. If I have an x-intercept, so now I'm on this line somewhere, talking about x-intercepts. Well, no matter where I'm at that, my y value, so now I'm talking about where will I be on this y-axis, well, I'll always be right there at 0. No matter where I'm at on the x-axis, the y number will always be 0, because I never go up or down. So no matter what, if you didn't understand all that, that's fine. Here's what you need to write down for your notes for a quiz, though. If the coordinate has a 0 in it, it's an intercept. It's either an x-intercept or a y-intercept. So again, and you could write if the point. Coordinate is the same thing as a point. If you want to write coordinate, this is how you spell coordinate. It's not a bad idea to understand that coordinate and point are the same thing. So with the coordinate, or again, the word point works, if it has a 0 in it, and I mean a value of 0, which I'll explain in a second. It's got to be a value of 0, the number 0. It has the number 0 in it, it is an intercept. You just have to figure out, is it a y-intercept or is it isn't. Now here's the second part. If you know that it's an intercept, so if you've determined it's an intercept because it has a 0 in it, the number, so wherever the number is in the coordinate, tells you which intercept it is. And we'll come back and I'll wrap that up in a second. So let me ask you again. Oh, and so here's the second part. If there's no 0 in it, it's neither. It can't be an intercept if there's no 0. So that maybe makes it even easier for some of them. You should at least get those right. So if there's no 0, then it is not an intercept at all. It's neither. I'll give you a second to write all that. So if there's no 0, it is neither. Or it's not an intercept, whichever one you want to write in your notes. So at least you should get the ones correct where there's no 0 in it. You don't even have to think about those. You don't see a 0, it's automatically. And by no 0, I mean the number 0 is not in it. There's a reason why I keep saying that. I'll go over that soon. So with that in mind, what is this first one? The 1, 3. What is that?
Neither.
What do you think? Neither. There's no 0 in it, right? It's neither. So that is neither. There's no 0. We can immediately say that's neither. That's either. So that's easy. That's how you spell neither, by the way. E first, I believe. Kind of dumb. Doesn't follow our rules. So what about the second one? 2, 0. Is that an intercept? Right now, just is it an intercept?
Yeah.
Yeah, it's got a 0 in it, right? It's an intercept.
Yeah.
Here's how you tell which intercept it is. You look for where the number is. If the number is in the X, then it's an X-intercept. Because that means this point, remember, this is 2, 0, it would be right there, which is on the X-axis. So it's an X-intercept. You could plot all of these, by the way. If you want to take a graph and plot them on a graph, and then just whichever ones are on the Y-axis or the Y-intercepts. If they're on the X-axis, they're the X-intercepts. And if they're not on either, then they're neither. But all you really have to do is say, is there a 0? Yes. Where's the number? Well, if it's in the X, it's an X-intercept. If it's in the Y, it's a Y-intercept. What about this one? Is that X, Y, or neither?
Neither.
That is neither. When I say if there is a 0 in it, it means the number 0. This is not the number 0. This is the number 0.4. I put a leading 0 to try to make it a little trickier, but just remember, that is not 0. This value is 0.4. So not 0. So that's a neither. What about this one? A lot more people were quiet on that one. It's neither. Again, just because there's a 0 in one of the numbers doesn't mean it is the number 0. That's the number -10. So neither. What about this last one?
Y-intercept.
Y. It has a 0, so we know it's an intercept, and it has a number in the Y variable spot or whatever. So it is a Y intercept. Going to be a few points on your next test, kind of like the slope and the y-intercept were, and I expect you to get 100 on that. You got a lot better explanation probably than some of the classes, because as the day goes on, I can correct things or fix them before I realize that people aren't getting it. So here's the next part. So that's all about intercepts. So we've done graphing in a couple of ways. Well, we've done it really in one main way, but we started it out with a different way. What is a line? Way back. What's a line?
Bunch of dots close to
Yeah, they're individual points. It's not like one solid thing. It's individual points. What makes them form the line, though? Why don't they just look like this? Actually, let me get. Why don't they look like this? Like, what is it that makes them form a line and not just be all over the graph?
now like straight.
But why do they line up and why are they straight? Like, what do they have in common that makes them not just be all over the place?
The line.
The points have like a pattern.
Ooh, pattern. I like that word pattern. Where does that pattern come from, though? How do they get that pattern? How do they know what the pattern is? No, they become coordinates. The coordinates themselves do not give them the pattern. Where does the pattern come from? No. Anybody gonna take a shot? Come from that. Come from the equation. That's what the equation. Why it's called the equation of a line. The pattern is really mainly the pattern comes from the slope, which in this case is 1. But the equation itself is what gives us the line. It gives us our starting point. Remember when we graphed, we said our starting point is the y-intercept, and then our slope is how we get to the next point. So the equation is what gives us kind of the pattern. But before we did any of that, we also said that the points have to make the equation a true statement. So basically they have to do this. Whatever points are on that line, they have to make the left side equal the right side. That's the best probably answer. Pattern is good. I like pattern. But ultimately, whatever 2 points we choose, we're not choosing them. Whatever 2 points, or whatever 2 x and y values that make up the point, if they are on the line, then they will make the left side equal to the right side. Because remember, we did that. One of your questions on the quiz, I gave you an equation, and I said something like, is that point on the line that's created by that equation? To plug that back in and see if the left side equaled the right side. We did that before. So we're kind of going back to that. So I want somebody to give me two coordinates, or an x and a y value that make that equation true. Makes the left side equal the right side. Well, you need an x and a y. So 4 and what? And which one would be 4?
4, 2.
5. 1.
So 4 and 2. Which one is the 4 and which one is the 2? Because again, you would be saying x would equal this, y would equal that.
I know.
I heard yours, 1 and 5.
Yeah, I think so.
What do you think, Ella? Give me an answer to this.
I don't know.
Say yes. Oh, I didn't. You got to put your phone in there and then you can go. So somebody said, or Wanderson said 1 and 5. Well, let's see. If that's true, it better make the left side equal the right side. So y is 5. X is 1.
Oh, I see what it is. Oh, all right. I got one there.
There we go. Perfect. What do you got?
Wait, hold on. Yeah. All right, 6.
I'll get you next. 6 and
62. Oh, no, wait.
which one is which?
2 and
Yeah,
6.
62.
2 and 6.
So which one is which though?
X is 2.
There you go. Good. So that's what we said. I'll go ahead and get yours now, Christine. 3 and 7. So now let's see if those work. Let's see if they are correct. Well, I'm going to test 2 and 6 first. So 2 is my x. I'll do this next. So 6 is still 6. We didn't do any math there. Perfect. Left side equals the right side. So 2 and 6 works. Let's test 3 and 7. Perfect. Worked again. That's not too bad on that equation, right? Like it's pretty easy to come up with numbers that work. So if we wanted to do this, we could plot these on a graph. 3 and 7, 2 and 6, 1 and 5. I could even give you, I'm going to actually pick a negative number. Oh, yeah, actually, I'll just do this. I'm going to tell you that this works also. -3 and +1. So now if we said, all right, well, let's create that line, we would just draw a line through all of those and boom. Notice how they all lined up. So that's another pretty good indication that they were giving me good points. Not only did we solve it out mathematically, but when we draw the line, it goes right through every point we just gave.
Why you put 2 extra points?
What do you mean, why did I put 2 extra points?
2 and 8.
2 and 6 you're talking about?
Yeah, 2 and 6, 3 and 7. Why you put those 2 right dots?
So this point here and this point?
Yeah, those 2.
Just because that's what we did on the graph. I just plotted these. I just plotted all of those, but I like where you're going. That's going to be one of my next questions. What if it gets a little tougher though? Ooh, I got to get rid of that. What if it gets a little tougher? Now it's not quite as easy to just figure out 2 points. It's not a whole lot harder. It's a little harder. So somebody give me one now. What do you got?
1 and 2.
All right, so 1 and 2. Well, I'm assuming you said it like that?
Yeah.
1 is X?
Yeah.
So, here's one thing I'm going to kind of throw into the lesson. Who knows anything about sports? Team sports, mainly. Team sports. Soccer works. Soccer's a good one. Ladies, you may be bored, but you got to stay awake for this. You got a big exit ticket on it. Soccer works. Basketball works. Football works. They really all work. Team sports work. What does it mean? Do you play soccer? You don't play here? Oh, so your brother did? Who am I going to call on? Leijah, since I just woke you up. You know anything about any sports? Team sports?
Soccer.
She plays soccer.
She on the soccer team.
You're on the soccer team? Nice.
It
You
sucks.
guys are doing pretty well. Oh, no?
That's not
Yeah, that's not cool at all.
0-5.
That's
It
not
wasn't
cool.
even 5.
Oh.
It was 4, right? No.
That's not, just knock that whole conversation off right now. We don't ever.
What is varsity even more?
That's not the culture we build in here. In soccer, you're in the game, or you're not in the game, either way. And there's a person that's on the field, and you guys are going to substitute for each other. What happens? Like just the simple version. You don't have to tell me the whole process, but like you're on the field, they're subbing in for you. What happens?
Switch.
Yeah, you switch. You come out of the game, right? And they go into the game. That's substitution. That's substituting. It is the same exact thing in math, in an equation. Did anybody else come out of the game? Did they do anything? Did the refs come out? Did they leave? Did anybody change? You came out, they went in. When you substitute in math, so this is my equation, and I don't know why this is as challenging as it is. That's the original equation. If I'm going to substitute in for variables, and I say x is 1, y is 2, well then those come out, so y is 2. Nothing else changes. The equal sign is still the equal sign. The 2 is still the 2. Now I am going to put a multiplication sign there because now that we have a number for x, I can't just write 2, 1, because then it looks like 21. But everything else stayed the same. I didn't take any other players out. I didn't take refs out. I didn't move the order around. Everything else, for some reason, I get kids plugging this in and then they change all the other stuff around. They lose a number somehow. Nothing else changes. Now we just do the math to see if it worked. So 2 subtract 4 should be 2. Not quite. You were close.
Oh,
It's a negative 2. So our number would have to have been negative 2 right there. If x is 1, y has to be negative 2.
yeah.
Give me another. Can anybody give me another number? I need to kind of move on.
Yeah, I got
Did you
it.
come up with one, or you have that?
Let me
2 and negative 4.
I thought you were raising your hand. Do you want to? Are you giving me an answer, or are you waiting on?
No.
Okay, what do you got? 2 and what?
Yeah.
0.
2 and 0. Let's try 2 and 0. I bet that's a good one. That's an easy one.
What about 2 and negative 4?
So again, if I plug in, so y is 0, 2 times 2, again, the 2 doesn't change, equal doesn't change, subtract doesn't change, 4 doesn't change. So I get 0 stays over here, 4 subtract 4. So yes, that worked, 2 and 0. What, did you have one?
2 and negative 4.
2 and negative 4?
No.
2 and negative 4 wouldn't work, because once you've used a number and that's the only number that will work with 2 for a while.
3 and what's the number 2?
3 and 2. So again, I'm going to do this one last one, and then we're going to talk about how we're getting those, for those of you that are not sure. So I plug in the 3, nothing else changes. Correct, 3 and 2 work. So here's what we're doing. I'll write you a pass in a minute, but not until I get a little point to break. So when I have an equation and I want to come up with 2 numbers, I could just try to guess and just pick any 2 numbers and see if they work. And that's not what they're doing. They're not just getting super lucky and guessing 2 numbers. Here's what they're doing. They're picking one number. They're picking any number that they want. And they're saying, and you've kind of used a lot of numbers, so I'll go the other direction. I'm going to use -1 for x. There is one number and only one number that will work with that -1 as a y. There's only one y value that will work in that spot. And the way I know that is I'm going to solve it. I'm going to say, again, substitution. I'm going to put x in the game. X is going to, or I'm sorry, -1 is going to go in the game. X is going to come out because I don't need x in there anymore if I know x is -1. So I'm going to substitute. Oh, let me just say times -1 and then subtract 4. So if I say 2 times -1, I get -2, then subtract 4 is -6. So what is the one and only number y has to be to keep the left side, because again, the left side has to equal the right side. What's the one and only number that will make the left side equal to -6, which is on the right?
4. Nah.
Lucas, what's the one and only number that will make the left side equal to -6? Not really a trick question, but it always makes me laugh a little bit when kids, they think it's a trick question. What's the only number equal to -6? -6. That's the only number equal to -6. So the only number y can be, in order to make this side equal -6 when x is 1, is -6. We literally could have just said, well, y equals that, and then finally, y equals -6. We could have brought the one, which is what we do when we solve an equation. We always bring the left side down, right? Well, in this case, the left side is just y. So we get down to where finally all we have is just y equals -6. So that's how they were coming up with those numbers. They're picking a value for x, plugging it in, and then solving it out and coming up with what y has to be. But here's the other thing, and I'll bet you probably didn't do it this way. You might have. I don't have to just pick a value for y. I'm sorry, for x. I could pick a value for y. And I could say, well, tell you what if y, whoops, what if y, I'm going to go with +4. Oh, no, I don't like +4. Yeah, I do like +4. What if y was +4? I can pick a value for either variable. It doesn't matter which. Now I just plug in 4. So now I'm going to substitute in, but now I'm trying to figure out what x is. So y is 4. I still have the 2x subtract 4. Again, all I did was substitute in y and 4. Flip them. All right, well, here's where you're doing a two-step equation. Because now we don't just do the math on this side. We have to say, okay, well, what's our two-step equation process? Well, we need to add 4 to get rid of that, which means we add 4 over here. We get 8 equals 2x. We divide by 2, divide by 2. So we get x equals 4. So 4 is what x would have to be if y is equal to 4 also. And it just happened to work out that they were the same number. So you can plug in a value for either variable. Doesn't matter which one. But you have to solve for the other one. You can't just pick one for the other one. You can plug something in for x and then solve for y, or you can plug something in for y and then solve for x. Either way, if you go back and recheck that, those coordinates, so these are just coordinates, by the way. 1, -2, 2, 0, 3, 2, -1, -6, and then 4, 4. We're just these are just different formats to write coordinates. You can write them in a table like this. You can write them in more of like a coordinate format, a point. Either way, it means the same thing, x and y values. Those should all form a line. So if we plot those, now I'll plot them. 4, 4, -1, -6, 3, 2. What am I missing? 1, -2. 1, 2, 3, 4, 5. 1, 2, 3. What am I missing?
4, 4.
I did 4, 4. I did 3, 2. Oh, 2, 0. Looks pretty good to me. Looks like those line up pretty well to me. So let's make our line. Make sure. Perfect. Line up perfect. Every single one of those better fall on that line, or else we did math wrong somewhere. So now let me ask you this question. Actually, this question right here. How many points did we really need to make that line?
2.
Do we need any more than 2? Like, if I would have just picked this point first and solved and then picked that point, couldn't I have just connected those 2 points and I would have had the same line?
Yeah.
Nothing would have changed. I could have picked the 2 points closer to each other. Done those first and then connect those and then continued the line all the way through. That would have been fine. You only need 2 points. The rest of the points maybe help you make sure you're right, because they should all fall on the line. But you only need 2 points. So what I want you to do, where are we at? Oh, I got to move forward. Okay, we're going to skip the next one. What if you get to the point where you have an equation like this, though? That's a little different than what we've been doing. We've been doing the ones that are kind of like in the same format, y equals mx plus b. I want you to try to come up with just 2 coordinates, 2 points. So you'll have an x and a y value and then another one that's an x and a y value, so you can make a line. And remember, it has to make the left side equal the right side. Little tougher there, right? Not in that same format we're used to.
Oh, I think I got one.
Alright.
Thank 1 9.
So 1 and 9. So 1 times 7 is, well, that wouldn't be right because that's going to be a negative number.
1 times 7. Yeah, 1 times 7 is negative.
Because, oh, did you say negative 9? Well, that would still be wrong.
Wait, what?
What numbers did you say?
1 and 9. Oh, wait.
Because 9 times negative 3 is negative 27. So that means it's going to be negative 20 would be the answer to that.
I don't.
What do you got?
4.
4 and what? 4 times 7 is 28. 28 subtract 12 would not be 21. Let me go ahead and cut to it. Because I need to go ahead and kind of get to the point. You still have to do this, which I don't think I've passed out yet. What are we doing though? How are we trying to come up with that number? We're doing what?
Replacing the y.
We're plugging something in and solving for the other variable, right?
Yeah.
Well, in the other format, it was a lot easier because y was all by itself. And we know how to solve those equations. We don't know how to solve these as well, so I'm about to tell you. You see something in this format and the variables are kind of on the same side. What's an easy number when it comes to doing math? It's like the easiest math you can do.
2.
1 is pretty easy. I'd argue there's one that's even easier. 0. 0 times anything is what?
0.5.
It's 0.
0. 0 times anything is 0. So if I plug in 0 for x, I'll do it over here. Again, substituting in just means that only the x changes. Still going to have everything else the same. So now I solve it out. Here's why 0 is so nice in these problems. When I plug in 0, this whole first term just goes away. Otherwise, if I've got a number there, if you remember your two-step equations, I've got to try to subtract that number out, whatever it is, and then subtract it over here, or add it, or something like that. So I just eliminated a whole step in the process of solving by making that equal to 0. Now I just say negative 3y divided by negative 3.
7.
Negative 7.
What?
21 divided by negative 3.
Oh. I thought it was.
So y equals negative 7. Now I'm going to do the same thing, only this time I'm going to plug in 0 for y. Because again, if I plug in 0 for y, it takes out the whole term that has the y in it. I don't have to worry about doing any addition or subtraction. Not that it's super hard to do it that way, but so negative 3 times 0. I still have the 7x, because now I'm trying to solve for x. Now they will not, so that goes to 0. They're not always going to come out nice and round and even like these did. I actually created them just so they would come out even. So x is 3. That's the only 2 points that I need to be able to create the line, to graph the line. So I could plot those. So 0, negative 7 is down here. 3, 0 is here. Oh, what's true about both of those points? Who am I going to call on here? Lazare, what's true about both of those points? Yeah, you do. Sure you do. You know something's true about both of them. You don't even need to know anything about math to be, well, I mean, I guess you need to know like your numbers. But what's true about both of those points? So maybe I need to go over that. So remember, these are points. 0, -7, 3, 0. We're just writing them in different ways. What's true about them? How come you know? Just visually, like don't even think about math. Look at them. What's true about both of them? What do they both have? They both got a 0 in them. What did we say that means?
That they're on the line.
They're an intercept. If they have a 0, they are an intercept. This is a y-intercept because we have a y number there with the 0. This is an x-intercept because we have a number in the x.
Zero, -7 is the y.
That's what I said. This is a y. I said this is a y-intercept because we have a 7 in the
Yeah,
y.
and
I would have said X.
This is an x-intercept because we have a 3 in the x. And plus, if we plotted them, if we put them on the number or on the graph, this one falls on the x-axis, this one falls on the y-axis. So you can always graph it if you're not sure. So now if I connect those, I've drawn the line. And my math was not too difficult, even though it's a pretty complex looking original equation. By using 0, I was able to solve out pretty easily. So if you haven't, I don't think we did it in here. You need to come up and grab, you actually don't need the graph paper today. I was gonna have you do more work, but come grab one of these papers. It says graphing lines in standard form.
And are we gonna solve them? You want us to do them?
If you want to start on it, you can start on it. I'm not done. I'm going to show you how to do one of them. I'm going to give you an answer basically. But one of the, I'm going to do number 2 for you. I'm going to show you another way to do it. I love Stitch. So everybody look at number 2. Well, once you sit down, you can look at number 2. So, I'm going to solve number 2 for you. I'm going to do it 2 ways. I like the first way better because that is a little more of a, how do I say it? It lets me know you understand what you're doing as opposed to just doing like a little trick. Let me do this first way and then I'll let you go. You'll still have time.
Can I set it at 18?
So I need 2 points. Again, I could plug in any number I want for x and then solve for y, or plug in any number I want for y and then solve for x. Could pick any one. But I want to make my math as easy as possible. So I'm going to choose 0. For this method, when you see the variables on the same side, this works out pretty well. And this is called graphing in standard form, or it's also called finding the intercepts, because we're finding the y and the x-intercept every time, because we're making one of these values equal to 0. So that's what I'm going to do. I'm going to make x equal to 0, and then I'm going to solve for y, and then I'm going to make y equal to 0 and solve for x. And then I got my 2 points I need. That's funny. So, oh wait, never mind. I'm wrong. So, I'm going to take, oh man. I'm going to take the x I'm sorry, the 0 for x and do the substitution. Nothing else changes. I just put 0 in for x. The 10 is still there. Subtract 3y. Like I said, it's just like sports. All the other players, the refs, everybody else stays right where they were. You just go in for whoever is coming out. that goes away. 10 times 0 is 0. So really, it just kind of goes away because we don't need to write down 0. Now I just solve for y. So I divide by -3, divide by -3 everywhere. I get y equals 5. So when x was 0, y equaled 5. So my first coordinate, is that an x-intercept or a y-intercept? This one right here, is that an x-intercept or a y-intercept? 0, 5. Is that an x-intercept or a y-intercept? Hearing both. If you think it's an x-intercept, raise your hand. And I'm going to call on you if you don't raise your hand at all. I'm going to call on you.
No.
Take note of who's.
It's not an X.
So raise your hand if you think it's an x-intercept. Nobody? I better see every hand go up on this one. Oh, if you think it's x, all right?
Wait, what am I thinking?
So raise your hand if you think it's a y-intercept. Valencia didn't raise her hand. Valencia, what do you think it is? You didn't raise your hand. I said if you didn't raise your hand, I was going to call on you. It is a y. The 0 tells us that it is an intercept. It's one of the two. It's either x or y intercept. The fact that we have a number there tells us it's a y-intercept. Because if I plotted that point, which I'm going to do anyway, it would be 0, 5 would be right there. It's on the y-axis. If it's on the y-axis, then it's a y-intercept. So now I'm going to plug in 0 for my y value. Solve out for the x. So again, now I write in 10x. That doesn't change. So there we go. So that really just, so I can write 10x, and I could write subtract 0, but really that just goes away. So now I divide by 10, divide by 10. I'm going to kind of take a real quick shortcut and just convert it to a decimal. So that is x equals negative 1.5. X equals negative 1.5. So I would write over here negative 1.5. So I could, again, what kind of an intercept is that?
That's an X.
That's an x-intercept. The 0 tells us it's an intercept. The fact that we have a number for x tells us it's an x-intercept. I don't like where I just wrote that.
Why does our papers have lines?
Yeah.
Because you have the answers.
So then what is the point?
Well, just like when I did it last time, I want you to still go through the process and solve it. But since you're doing most of this without me there, because this is your homework, if I'm not there and you put those, it's not due tomorrow. It's just to help you study. I mean, I'm still going to grade it. I am going to grade it, but I'm not going to necessarily grade it Friday. I encourage you to do this on Friday. Your exit ticket. So for example, you already have the line on there. You would have done the points and you would have put them right here, and then you would have put it right there, and you would have known you got it right because they fell on the line that was already on the paper. If you didn't have a line there, you'd have no idea if you did it right. That's why I left the line. You still do the same process and you create 2 points, and then you put those 2 points where they should be on the graph. Don't just look at the line and put 2 points on the line. Truly look at the points you created and then put them where they should be on the graph. If they're on the line, then you know you did it right. If they're not on the line, you need to go back and check what your math was, or maybe even where you applied the points. So one last thing I'm going to show you. So here's a method that is if you don't get anything that we just did, you need to tune back in right now. Because I'm about to show you the shortcut version, which I hate. Because it means you can have absolutely no understanding of what I'm doing and use this method and it works. But I don't want you to not understand it. I want you to understand it. But I'd rather you be able to do this than nothing. This is called cover up and solve. So if you have an equation where you have both the variables on the same side. And it's like something plus something, or something x subtract something y. What you do first is cover up the first term. So literally cover it up, scratch it out. You don't have to erase it then and scratch it out, but cover it up with your finger. Just put your finger on it. Now you just solve out what's left. So you just solve out negative 3y. So you divide by negative 3, divide by negative 3. There's only going to be one step when you do this. You're just going to divide. It's the only step. Because there's no other term to add or subtract. Gives me y equals 5. So I'm going to write it over here. So that gave me y equals 5 when I covered up. Now, and I got to get rid of it. So if you get y equals 5, you just go to the y-axis and put a dot on the 5, which is the same thing we just did. But I tried to show you the reasoning behind it. Now I'm just telling you what you can do. So now, same thing, only we're going to, instead of covering up the first term, now you're going to cover up the second term. So now we've covered up that term, and we're going to solve 10x equals negative 15. Divide by 10, divide by 10. Again, you get x equals negative 1.5.
Oh, so what the...
So when you get x equals negative 1.5, now you just come to the x-axis, and you put a point on negative.
Oh, so the cheat
1.5.
version, you just...
It's the same thing I just did, only I was trying to explain that you're plugging in 0 for x and then solving for y.
By the way, cheat version, you just block out the bit of
Well, and the reason why blocking it out works is because if I plug in 0, if I'm plugging in 0 for x, well, the whole term just goes away because 0 times 10 is 0. If I plug in 0 for y, that whole term just goes away. But I want you to understand that the point, the coordinate is actually 0, comma, whatever it was, 5. And the other point is actually negative 1.5, comma, 0, because we plugged in 0 for those values. But if you didn't understand that, you can look up cover up and solve. I would guess it would come up. Cover up. If you're really not understanding this and you still want to do well on the quiz, cover up and solve, and it'll tell you how to do
what's
this.
negative 6 divided by 1?
Negative 6. Anything divided by 1 is the same number. Now you still have 5 minutes, so if you're not getting this, don't pack up. Because you got another 5 minutes and you can try to get it and I can help you.